welcome to the October meeting of the...
Live streaming is on.
Welcome to the October meeting of the Baton Rouge Astronomical Society. We have quite a nice little crowd here with us tonight, and which is it's nice to see more and more faces coming into the observatory, and well, masked as they are, the top half of the faces at the very least. We'll see the bottom half eventually as time goes by. I should imagine. We hope. Tonight's speaker is going to be Amy Northrop Brie, if I got that right. She is our local solar system ambassador, and she's going to be talking to us about the Lucy mission. So that having been said, I'm going to let her jump right into it and enjoy the presentation, and we'll have the rest of our meeting afterwards. Give me a second, I'll mute this so that we won't get the feedback. And yep, we can now turn on the speakers on the other thing as well. And Amy's in charge.
Well, it would help if it stopped being temperamental and actually pulled up my slideshow. Fine, I'll just have to minimize Jitsi. Okay, so
Or you can stand in front of the slideshow.
I don't want to block people's view of it. I worked hard on it. So this patch shows the namesake of the spacecraft and the namesake's namesake. For those who need a little background, this on the very corner is the human ancestor Lucy, which was given its name by the Beatles song Lucy in the Sky with Diamonds, which started playing as they were unearthing the fossil, which is why the patch is diamond shaped. The more you know, the funnier it gets. Oh, what on earth?
Yeah, that was a quick one.
All right.
Okay.
Y'all come on back next week. Next month is going to be.
I don't know if this is intentional, but the camera is pointed toward the audience, and I don't know if that's what's going to be on the YouTube presentation. Not that I have any problem seeing the audience, I just can't see the slideshow.
No, you should be able to see the slideshow. It should be coming up, and actually, we can change this just a little bit.
Okay, cool.
Yeah, the audience, the presentation is what's going to show up on the slideshow. If I can remember how to do the. Yeah, there you go. Yeah, so this list of people isn't going to show up on the YouTube. I don't think. I never checked. I can't stand the sound of my own voice, and so I never watch it for long.
I was trying to be fancy and use the clicker. Apparently, Jitsi doesn't like the clicker, and when I tried to use the clicker, the thing happened. Okay, so the spacecraft has many instruments on it. The L with the little apostrophe means it's just the Lucy version of another instrument that was used on another spacecraft. The Lori instrument is a very high-resolution camera. Ralph is a multi-spectrum camera, and it actually has 4 different instruments that lets them view it in multiple wavelengths, which I will spare you the very long acronyms because, wow, they really love their acronyms. And the TT cam is the terminal tracking camera, which is used for centering its targets. And LTES is a thermal emission spectrometer. Now, for the mission, it's going to be a 12-year mission to the Trojans with a main belt asteroid test in 2025. And it's going to encounter 5 objects, have 5 different encounters, and 2 of these are multiple encounters because one of them they discovered a moon on, and the final target is a binary pair. Now, what's a Trojan? Trojans orbit in front of and behind an object in their orbit. These locations are called L4 and L5 after the mathematician Lagrange, who discovered or theorized these points, and we now know they're true. And this animation shows that they, in fact, orbit a point. They don't just hang out in Jupiter's orbit, because you can see them circling points in front of and behind Jupiter in its orbit. From this perspective, the L4 swarm is at the top of the image. And this was, I had to pick this image because it was the only one that didn't show them all moving crazily with the planets in the center spinning around like crazy tops.
Is on.
Okay.
All right, if y'all could mute yourselves when you're not presenting, that'd be great.
Okay, now, why the Trojans? There are fossils from the formation of the solar system. Okay. It says I just got mute. It says I've been muted by Meryl, but I'm not listed as muted.
Okay. Yeah, I can see your audio going up now. Everybody can get thumbs up if you can hear. Everybody. Well, the crazy thing about asking for thumbs up is everybody's turned their camera off.
Okay. Do I need to start over? Or
Amy, your audio was muted for a few seconds.
okay.
So, yeah, just keep going.
Okay.
I've muted everybody but you. Like somebody must have muted you. Somebody hit a mute all the time. Okay. So sorry about that.
And since they've been captured by Jupiter's gravity through Jupiter's moving about the solar system, it's captured many different populations of asteroids, which allow us to sample a wide variety of asteroids from different populations by going to a fairly small target area within the solar system. And now for the timeline. The launch window opens this Saturday. Hopefully it will launch early in the morning this Saturday, and its launch window ends early November. There will be 2 Earth gravity assist, and then the main belt rehearsal, which I actually find the target quite amusing, which I will get to why in just a moment. This is the trajectory. The orbit of Lucy will, at the final stage, achieve a resonance with Earth's orbit, so it can come back, do a gravity assist to sling it to another cluster. So if the spacecraft is healthy at the end of its mission, it can keep going back and forth between the 2 swarms of the Trojans as long as it is in good health. Now, the targets. First one is actually a main belt asteroid by the name of Donald Johansen, which I find amusing because that is the name of one of Lucy's discoverers, as in the fossil. So I find that amusing. This will be an asteroid test, and I apologize for the size. I have all of these. I took one image from NASA that has them all to scale, and I scaled them the precise amount so you'll be able to see their sizes in relation to each other. And this asteroid in the main belt is tiny by comparison. And next up, we have Euripides and Queta. Queta actually is not present in this image because the moon was discovered after this image was made. It is a C-type asteroid, which is odd. C-types make up a very, very small percentage of the Trojan asteroids. And it raises some interesting questions. They aren't sure why they're rare. And it's the largest remnant of the only disruptive collisional family in the Trojans. And we haven't visited any object like this before. They're not sure why C-types are rare. There are several possibilities that the head scientist, Howe, Dr. Howe, and his last name escapes me, I think it's Johnson, says. He said there's no D-type families in the main belt. They are wondering if perhaps D-types disintegrate when they're impacted, or perhaps they become C-types when they are hit. D-types have a red coloration to them, and they're wondering if that red coloration is just on the surface and if that disintegrates or disappears when they're impacted. And Lucy will help us unravel this mystery. Now, Ptolemy is the smallest of the Trojan targets. It is in the L4 swarm and is a P-type, which is different than the D-types I was speaking of earlier. And an interesting note on the names. All of these names are Greek in L4 swarm, except for one asteroid that is named for the Trojan prince Hector before they set the naming trends. The L4 swarm or camp is named for Greek combatants in the Trojan War, and the L5 swarm is named for Trojan combatants in the war, but there is one spy in each camp, and we're going to meet one of those spies in a little bit. And Lucius is one of those D types I spoke of. It has a little bit of a red cast, and this encounter will happen just after Lucius aphelion. And then within the same year, we will meet Orus before Lucy comes back home for a brief visit. It will have a gravity assist to sling it to the other swarm, where we will meet the Greek spy, Patroclus, friend of Achilles, and the binary pair that are these objects. These are almost spherical, as physics describes them, they are almost have the hydrostatic equilibrium, and they almost have a circular orbit. And this object is incredibly interesting because many of the cold classic Kuiper belt objects come in binaries, like Pluto and Charon, and Arrokoth, the object that New Horizons visited afterwards, is a contact binary where two objects just kind of got closer and closer and then just stuck together and became one object. Now, for the future, I mentioned that Lucy has an orbital resonance with the Earth. Its orbit is a multiple of Earth so that it can always come back and get a gravity assist. And as long as Lucy is healthy, we could keep exploring the Trojans almost endlessly until the poor spacecraft eventually wears out. But that will probably be a long way off with how well NASA builds things. The Voyagers are still going on. Okay, are there any questions?
And what's the power source?
Solar panels.
Okay.
It is a massive pair of solar panels that are folded up. They're made of little triangular segments, and they unfold into two circular shaped solar panels, as visible on one of my first slides. Okay, any other questions?
How large is the asteroid?
Oh, it's unmanned.
No, how large is the asteroid you're visiting? If they're spherical, how large?
Oh, I didn't actually mark theirs, but they are a few, I think a few 100 kilometers in size. Patroclus and Menelaus are. All of the others are sized in the images comparable. So Donald Johanson is a very tiny asteroid.
How do we know what we know about them thus far? Where
For their classes, they determined that with spectrographic imaging and basically how they interact with the others via Doppler shifting. A lot of these actually, I believe, were done with Arecibo. Some of them were.
Yeah, that's what I wondered, if it was some grad student's hell or if it was.
Well, I know that the moon Queta of Euripides was discovered with images from the Hubble Space Telescope. They were trying to refine their estimates of the mass, and in a few of the images, they saw this grainy little white spot next to one, and they're like, "Is that what I think it is?" And they're like, they kept looking a little more, and they're like, "Yep, it's a satellite that we've never seen before." Okay.
What's the name of the new satellite?
Queta, Queta.
Is it the furthest one out? Yeah.
Probably. As far as satellites, I don't know whether it is we aren't sure if it's an unusual thing. There may be others we just haven't found yet, because Euripides is part of a collisional family. It's not unlikely that there are others of that same family that captured other fragments. The others just got thrown out of Euripides' gravitational field before it could snag them. Okay. Any other questions?
Are the Trojan asteroids, are their orbits stable over a long period, or is that just temporary?
They are very stable, but they can be disrupted if another object goes past them. They're not perfectly stable, but they've been here for hundreds of millions, if not billions of years, and they still seem quite content to just stay there, but they do occasionally swap locations, orbiting the L5 and L4 points.
Do the other gas giants also have Trojans?
Saturn has quite a few. I believe Uranus and Neptune does, and even Earth has a Trojan, but ours doesn't. They're not really sure if ours is stable yet because it was only discovered a few years ago, and they're like, wait, we have a Trojan too? As to my knowledge, no other planet, none of the other terrestrials have a Trojan. But then we are the biggest kid on the block, so.
Is there any systems like lasers or anything where they'll be able to identify minerals or composition?
She does have several spectrographs, so she will probably be able to determine their compositions via that.
Like on Mars, they use a laser sometimes to take a spectrum of it. I didn't know if they have that ability.
I have.
Fully use the spectrograph on that to see if you can figure out where these Trojans came from.
She has an infrared imaging spectrometer. The linear, which is part of the linear Eidolon imaging spectral array, which both of them together are called LISA. And she also has a link to the Deep Space Network to better refine their masses using Doppler shift.
One thing that I always thought was interesting is that when we see images and like we watch Star Wars, we think these are just so close together, but they're actually pretty spread out. How far apart are these?
Well, one of them, they actually will be. I have the actual dates in here. One of them, they'll actually be Euripides and Queta. Less than a month later, they'll be coming up on Ptolemy. So these objects are fairly densely packed.
What's Ptolemy?
It is a tiny P-type. It's actually the smallest of the asteroid. It's in the Trojans. It's this little guy.
In the Trojans, some of these asteroids get over probably maybe 1 billion years on and bumped into each other. Now, I wouldn't be surprised if not little bits of gravel and sand out there between them.
Well, that's part of why there were 2 targets that Hal Johnson wanted to send spacecraft to independently before Lucy's trajectory was refined. And one of them was Euripides because it's the largest fragment from a collision. And it's one of the few C-types in the Trojan asteroids. So they're hoping to figure out what if there's a connection between the C's and D type of asteroids.
So it sounds like that these guys are a lot more densely packed than the main field asteroid belt, because you're talking about condensing the gravity area to these small Lagrange points as opposed to being a complete orbit around the sun.
Yeah.
So as the asteroid belt, you'd think of being
like the swarms tend to stay within the confines of these circles here, and as this animation shows, you can see them orbiting around kind of a central point. So
if you've got thousands of these guys in a small area, they'll occasionally run into one another. I think that's it, which is interesting. Like it's so common to think of all asteroids being the same, which they are, but it's the gravity is going to make all the difference.
And back to Coy's question, how are they able to know as much? There were a lot of graphs that they were showing that I unfortunately was not able to snag during one of the talks they gave. Not for lack of effort, but one of them showed the mass breakdown and velocity breakdown, and right on Euripides, you could see a little line offshooting of all of its little sibling fragments. So there was this little anomaly and kind of disrupting this plot of all of the other ones, and they're like, something happened here.
Really kind of curious to think of it as one object that started off as 2 objects colliding and then just like cascading.
Well, as Patroclus and Menelaus show, some of these objects just hang out together. And they're part of why they're interested in Patroclus and Menelaus is they're wondering if this will teach us more about the classic cold Kuiper belt objects. Yeah. What a mouthful. And why so many of those are binaries. And maybe we'll be able to tell, were they binaries when Jupiter caught them, or did they become binaries afterwards? Because that's another interesting thing of.
Yeah, if they're the same material, it's reasonable to assume they showed up that way.
They are both the same class, and they're similar in mass.
And I mean, the people that are exoplanet enthusiasts are going to find this interesting because everything that they're studying, you're bound to have the same phenomenon in other solar systems.
Well, they first called it the Grand Attack model, and then they changed it to the Grand Tack model when they realized had to figure out what made Jupiter stop coming inwards like a hot Jupiter. They think that the secret to why Jupiter didn't fling everything out inwards is Saturn formed afterwards, and its gravity pulled Jupiter back outwards. Because original simulations showed that Mars should be a super Earth, but something stole the material it needed to grow to that size. And when they're like, why are all these gas giants orbiting so close to the star? It made the planetary scientists wonder, could Jupiter move? So that's part of why the Trojans are so interesting. It collected so many fragments during its migration that we have fragments from all over the solar system that would have gotten eaten by the planets potentially. So, like, why are C-types rare? We don't know. And there may be solutions to that question that scientists haven't even thought of yet that Lucy will reveal.
So that's what I've been thinking about the whole time. When you think about solar system formation and everything that happened from, forming a disk to, all the material kind of gravitationally being bound and pulled together, and then planets forming and the outer belts forming. how this fits into the grand scheme of things. What mix do we have in this? That's what hopefully they hint at when they do the mass spec.
That's why Lucy is one of my favorite missions right now, because there's literally, even though it's going to take us 12 years to reach all of these targets, there's so much we can learn. Okay. Any other questions? Okay. I think it's back over to you.
Should have gone ahead and asked online for online questions. We already had online questions, and if you could mute everything for the yourself.
Hold on, it's still stuck in the slideshow. Why does this thing not like me? And where's my mouse? Oh, that's why.
You have heard the latest from Dr. Lucas about asteroids, all this debris. He said a long, long time ago that Death Star next year.
Yeah, I was gonna wonder if somebody was gonna actually venture to ask the opinion that just because we haven't seen it yet doesn't mean there's not an alien star cruiser hiding in the Trojans. Which, yeah, and until we see it, we won't know for sure whether or not that's true. But technically, we're sending an. Yeah, technically, there's Russell's teapot too. But technically we're sending the alien.
Muted now, so.
Yeah, okay. Amy is now muted. Yeah, you can turn that on to the thing so that we get a shot of the. And then, all right. So I think that's. Thank you very much to Amy for her talk. I think that we're going to go ahead and end the YouTube portion and the live broadcast to the public, and then we'll carry on with our meetings. Other than to say that for general members that we do have the membership dues are starting to be collected now, and we'll have sales of astronomy catalogs are going to be starting immediately, and these are going to be available to us at a club discount. So that go through us if you can, and we'll get them to you. All right, I'm going to go ahead and wait, we got some chat. Yep, somebody muted me again, or I muted myself, which is entirely possible, and nobody would blame you if you tried to mute me.
Oh, it was Thomas commenting that my microphone had gotten muted.
At some,
I think when the bad warbling happened, I think Meryl muted everyone and accidentally muted me.
All right, so thank you all for joining us for this the October meeting of the Baton Rouge Astronomical Society. Hopefully y'all heard some of that. Apparently we've been having some technical errors. I'm not sure exactly why, but